Okay, so we are doing our first lesson in our chapter over trigonometry. So we are going to start with some right triangle trigonometry. Just to review, right triangle means that there's a 90-degree angle for that triangle. So trigonometry is just the study of triangles and the ratios of those triangles. And then for this particular chapter, we're only going to be looking at right triangles, but trigonometry does kind of expand beyond that. And your triangles don't necessarily have to be right triangles, but for this particular chapter, we're just looking at right triangles. So right triangle trig, as we like to call it, what we can do, if we can know just one side and one angle, we can find all the other sides and all the other angles of a right triangle. So there are 3 sides and 3 angles. We already know one angle is 90 degrees, and if we know one other angle, then we can find the third angle by doing 180, because a triangle adds up to 180, its angles does, minus the 90, minus whatever the other degree is that we know, and that will give us our third angle. And then we can use our Pythagorean Theorem to solve for our sides. So, right triangles. The angle is always opposite the side with the same letter. So if I have angle A, then the side opposite is side A. And then the hypotenuse is always going to be the side opposite the right angle. So whatever side is opposite of the right angle, we call that side the hypotenuse. And the other 2 sides of the right triangle are going to be called the legs. So you have 2 legs and a hypotenuse, and that's what makes up a right triangle. So here is a picture of a right triangle. So you'll see that side C, which is in lowercase c, is across from angle C, which is a capital letter, and angle C is a right angle, which means that this must be the hypotenuse. Side C is the hypotenuse, which means that leg B and leg A are side A and side B are the legs. Notice that side B is lowercase, and it's across from angle B, which is uppercase, and side A is lowercase, and it's across from angle A, which is uppercase. So opposite and adjacent. So we know what opposite is. Opposite is going across. Adjacent means next to, right? So from angle B's perspective, if we are here and we're hanging out over here at angle B, we would say that side B is opposite, and we would say that side A is adjacent. And you could be like, well, is side C adjacent as well? And the answer is no, because side C is a hypotenuse. So when you're talking about ratios, you're talking about adjacent, you're never going to use the hypotenuse as a value. It's always going to be the adjacent side that is not the hypotenuse. So A would be adjacent to B, and side B would be opposite angle B. Now we can switch locations and we can go hang out with our friend angle A, and when we are hanging out with angle A, the opposite side would be side A, and the adjacent side would be side B when you're looking from angle A's perspective. So once again, the hypotenuse is never, ever, 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 ever going to be considered the opposite or adjacent side. Okay, so here is some practice. Let's say we want to figure out what we're supposed to label this side right here, the side between angle X and angle Z. So here are your options. We can either label it X, label it Y, label it Z. Okay, you should have chosen option number 2. You should have labeled it side Y. And the reason why is because it is opposite of angle Y. All right, let's do another question. Which side, there's 3 sides here, there's H, J, and K. Which side is the hypotenuse? Okay, you should have picked side H because side H is opposite or across from that right 90-degree angle. So that means that side H is the hypotenuse, which means sides J and side K are going to be the legs. Okay, next question. Which side is adjacent? And adjacent means next to angle X. So here's angle X. So what side is adjacent to angle X? Remember, the hypotenuse cannot be used. Therefore, side Z, which is option 3 here, is going to be adjacent to angle X, which means side X would be opposite of angle X. All right, here's another practice problem. How should this side right here be labeled? So it's the side between Z and Y, and it's opposite of angle X, which means we need to label it with a lowercase x, and it will be side X. Here's another one. So this side is opposite of angle P, which means that it needs to be labeled with a lowercase p, which is option 3. Okay, try this one. All right, so this angle is the right angle, and it is opposite of the hypotenuse, which is side T, which means that you should label this angle, angle T. And remember, it needs to be a capital T, which is option number 3. All right, now, which side is opposite to angle X? So angle X is right here, and we go opposite would be, it would be 4, the number 4, so which is option number 2 here. Okay, which side is opposite to angle K? So here's K, so we go opposite, and we see a 5. So 5 is opposite to angle K. Now we're looking adjacent to angle L. So here's angle L. Adjacent means the leg, not the hypotenuse. That is right next to the angle. So 13 is your hypotenuse, so you don't want to use him. And that means that the adjacent side would be this side here, which is the 5. So that would be option number 1. Okay, now we need the adjacent side to angle T. So here's T. Now S is the hypotenuse, which means we don't want to use S, which means the adjacent would be right next to T would be side R, which is option number 1. So something that we can use to help us solve for missing sides is the Pythagorean Theorem, which is a squared plus b squared equals c squared. And remember, c is always going to be the hypotenuse, and a and b are the legs. So often you're given just 2 sides of a triangle, and you have to solve for the third side. You can use the Pythagorean Theorem to find the missing side, and then once you know all 3 sides, you can identify the trig ratios. So let's go over the trig ratios. They have very peculiar specific names. The first one is called sine. So sine is the ratio, and ratio means fraction, of opposite over hypotenuse. So you're looking for the opposite side divided by the hypotenuse of that triangle. So your second ratio, trig ratio, is called cosine. And cosine is the ratio or the fraction of adjacent over hypotenuse. So you're looking at your adjacent side over your hypotenuse. And the third trig ratio is called the tangent. And tangent is opposite over adjacent. So there is a handy way to memorize the ratios of sine, cosine, and tangent. We call it SOHCAHTOA, so SOHCAHTOA. And the way that you remember it is that the letters are the first letter of the words. So S is sine, and then notice how we abbreviate sine to SIN, and then O is the first letter of opposite, because that's what goes in the numerator, the opposite, and the H stands for hypotenuse, so that's your SO, and then you have CA. So notice how the C stands for cosine, and we abbreviated cosine to COS. And then the A in CA stands for adjacent, which is the numerator of your cosine ratio, and then the H stands for the hypotenuse. Then you have TOA. The T in TOA stands for tangent. Notice that we abbreviate tangent to TAN. The O in TOA stands for the opposite, and the A in TOA stands for adjacent. So that's just a way for you to help you remember the ratios of sine, cosine, and tangent. All right, so if we want to find these values, let's say we wanted to find sine of angle A. So remember, SIN is the abbreviation for sine. So sine is the trig ratio of opposite over hypotenuse. So we would find angle A, and we need to find opposite over hypotenuse. So opposite would be 5, and the hypotenuse of this triangle is 13. So sine of angle A would be 5 over 13. That means cosine, which is adjacent, would be 12 over 13. Tangent is opposite over adjacent, so that would be 5 over 12. Now let's do angle B. Angle B is over here. So to find sine, we would go opposite, which was 12, and put it over adjacent, which is 13. So sine of B would be 12 over 13. Cosine is adjacent over hypotenuse. So cosine of B would be this 5 over 13. And then tangent is opposite over adjacent. So that would be 12 over 5. So let's do a practice problem. Find sine of x. All right, so sine is opposite over hypotenuse. So you would go to where x is, and you would find the opposite, which is 6. And you would put it over the hypotenuse, which is 10. So you have 6 over 10, and then 6 over 10 reduces to 3 over 5, which is option number 2. Now let's find sine of angle y. So here's angle y. So you would go opposite, which is 8, and put it over the hypotenuse, which is 10, and 8 over 10 reduces to 4 over 5. If we want to find tan of x, tan is opposite over adjacent. So it would be 6, which is the opposite, over 8, the adjacent. So 6 over 8 reduces to 3 over 4. Now we want cosine of y. So here's y, and cosine is adjacent over hypotenuse. So it would be 6 over 10, which reduces to 3 over 5. All right, so here's an example of how we can use Pythagorean theorem. This problem wants us to find the hypotenuse. So we can use the Pythagorean theorem that says a squared plus b squared equals c squared. So your a would be 3, and your b would be 2. So you would have 3 squared plus 2 squared equals c squared, and you're trying to solve for c. So 3 squared is 9, and 2 squared is 4, And 9 plus 4 is 13. So 13 would be equal to c squared. So to solve for c, we would square root both sides, which means c would be the square root of 13. Okay, here is another example. We have cosine A. So here's angle A. And remember, cosine is adjacent over hypotenuse. So you have 2 over the square root of 13. And when we studied radicals, we learned that we don't like to have the radical in the denominator. So we have to rationalize the denominator by multiplying both numerator and denominator by the square root of 13, which would give us 2 square roots of 13 in the numerator and then just 13 in the denominator, which is option number 1 here. Okay, here is another example where we want to find a side. So we're trying to find side x. So we're given one leg and a hypotenuse. So that means that we can use the Pythagorean theorem, except for we're trying to find 4 squared plus x squared equals 10 squared. So notice that the hypotenuse, the 10, went over where the c goes. So let's see, 4 squared is 16, and 10 squared is 100. And then we'll do 100 minus 16, which is 84. And then that means x squared is equal to 84. So we cannot leave it just as the square root of 84, though. We have to simplify the square root of 84. So you can do a factor tree. I know 84 is divisible by 4. That goes 21 times. So 84 is the same as saying 4 times 21. And the square root of 4 is 2. Which means that the square root of 84 is the same as 2 square roots of 21, which is option number 1 here. All right, this is our last example. We want to find sine of z. So here's z, and z is opposite over hypotenuse. So your opposite is 4, and your hypotenuse is 10. And so 4 divided by 10 reduces to 2 over 5, which is not any of the options given. So we would just select this option here.